The more that we understand about the neurobiological basis of the brain, the greater the implications are for how we understand personal responsibility for our behaviour. If our behaviour is the result of changes in our brain, are we responsible for those behaviours? Neuroscience is the study of changes in the brain that underpin our behaviour, our thoughts, and who we are. As these technologies move from the lab and into the clinic and then out into society, there's things that not just clinicians and scientists are going to have to deal with, but people. And we need people working within the field of ethics, neuroscience, the law, philosophers, and the general public to have an open discussion about how they want these technologies to change their lives.
We can make a better world if we think about the choices that we're making and we try to live in accordance with values that we've reflected on. Our best psychiatrists are still often completely bewildered when it comes to what's making people behave in certain ways and what mental illness consists in.
Our brains have historically in many ways been considered sort of chemical organs because the drugs that we use to treat disorders influence brain chemicals. But the brain is really profoundly an electrical organ. Everything that happens millisecond by millisecond in the brain occurs because of the electrical firing of nerve cells.
Deep brain stimulation is a technology that allows us to implant electrodes deep within someone's brain to be able to control activity.
Deep brain stimulation is an invasive, risky procedure that is really only being limited to the treatment of the most treatment-refractory illnesses.
Deep brain stimulation, while it is enormously effective in treating someone's motor symptoms, it can have really unexpected impacts on people's lives. Some people almost become addicted to the stimulation. They'll turn it off and on just because they want to get that buzz. And some people have gotten into quite a lot of trouble with some compulsive behaviours around shopping, hypersexuality, people going out buying Porsches and cars, and behaving in ways that they wouldn't have done previously.
I think that neurosurgeons would say that they understand the brain, but one of the challenges around DBS is that the ways it affects individual brains differ profoundly from one person to another, and that's what's unknowable.
The state-of-the-art treatment for depression, which is either give people a drug that changes their entire brain activity or, zap them with electricity. This is as though we were repairing a car by pouring petrol over the engine. We simply don't understand what makes the mind work.
When a procedure is presented as a solution, patients assume that everything is known about what the effects of that might be. But we know from DBS that's not the case. And I think making that clear to people is a really important ethical issue.
We're seeing the emergence of these, what they call non-invasive brain stimulation devices, which are essentially putting tiny electrodes on the surface of your scalp. We have very little evidence to show that they actually work.
I think if you go onto the internet and find the web page of a company selling a device to improve your performance in, some shoot-'em-up video game, it's not likely that that company is going to provide you with the evidence of the safety of that device. There are already athletes using types of brain stimulation to try to enhance their performance. We just don't know how effective these things are going to be and what the risks really are when they're being used long-term by healthy individuals.
One of the most exciting things in brain science looking forward is the development of what they call brain-computer interfaces. And these are devices which either go on the scalp or on the cortex of someone's brain to be able to decode the activity and to be able to infer people's thoughts, to be able to read their speech. The huge ethical question is around privacy and confidentiality. Who has access to our brain data? Who has access to our thoughts? And if they have access to it, can they control it? We already see this with the internet. We have very little control over our own personal data. If we add to that the very essence of who we are, our brain activity, that really opens up a massive Pandora's box.
So it's one thing to use these new advances in neuroscience to treat serious illness. It's another thing to use them to medicalise social deviance.
It is a little like a Philip K. Dick story. I think one of the interesting things about neurolaw is it is almost like science fiction, but it's happening now. Now is the time that we need to be taking steps to work out how to deal with these issues, how to regulate them in a legal sense, whether we want to allow these things to affect our society.
How do we hold someone morally responsible for their behaviours when they're taking a medication that is treating a neurological disorder, which they need to be able to function normally?
The brain is such a complicated organ that the ability to say with any certainty what is going on, I think, is very difficult. And so while that information is crucially important if you're talking about treatment of people, of helping people, that's a very different context than when you're talking about imprisoning people or detaining them or depriving them of their rights. And that's where I have real concern.
I'm quite sceptical that brain science is going to be able to predict those who are likely to offend or to identify those who are lying.
There is a risk that the use of brain scans and other neuroscientific evidence is progressing too rapidly.
Just because certain colours light up on a scan, it will tell you that there's blood flow and activity occurring in that part of your brain, but it doesn't tell you what is actually occurring in the brain. It's like a computer feels warm because the central processing unit is creating heat and there's a lot of electrical activity in the computer, but it doesn't tell you what the computer's doing and what the algorithm is running in the computer. You're just using a very crude way of looking what the brain is doing. But to say that there was activity in the visual cortex and that means that this person is guilty, it doesn't make sense.
I don't think we will ever get a day where neuroscientific technology will allow us to predict with any accuracy whether a crime will be committed. Now, that's not to say that people won't claim that that is possible or that the technology won't be used for those purposes.
I think we're better off dealing with objective evidence to decide if someone's guilty of a crime or not. I mean, really, rather than people's subjective interpretations.
Two things we know about science. It's enabled great progress and improvement in human welfare, but it has also served as cover for a lot of human rights abuses and allowed people to dress their bigotry up as medicine or science.
We live in a very complicated world. Not everybody understands it. Scientists don't know everything, and fairly often scientists will say things that later are shown not to have been true.
I think that we need to be realistic about actually all the knowledge we have about human beings already and the limits of insight when it comes to reshaping human behaviour.
It's definitely not a runaway train. We're definitely in control of what impact these technologies have on our lives. The aim of neuroethics is to make sure that we realise all the benefits that we want from these technologies while avoiding some of the pitfalls and unexpected harms.
We don't want to surrender to the neurosciences altogether. We want to remain critical, and so we need a distance from them. And we do want to keep the neuroscientists accountable to the human dimensions and the social impacts.